Hello students. Today we will learn about the molecule. In a chemical reaction, the elements are always represented in their molecular form. A molecule is electrically neutral, usually represented as a group of atoms held together by chemical bonds. It is the smallest entity that can exist independently. Now let us see the difference between atoms and molecules. Atoms are tiny particles of an element that can or cannot occur freely, while molecules are usually a set of atoms that comes together by a bond. Also, they are the smallest unit of a compound. Atom may or may not exist freely. On the other hand, molecules can exist in a free state. Atoms are very reactive. In contrast, molecules are less reactive. Examples of an atom are H, O, He, while that of the molecule are He, CH4, HF, H2, and O2. The molecule is further divided based on atomicity and based on substances. Based on atomicity, it is divided into monatomic, diatomic, and polyatomic, while based on the substance, it is divided into the molecule of an element and the molecule of a compound. Monoatomic molecule means uncombined molecules whose atomicity is 1. For example, helium, neon, and argon. Diatomic molecule means there are two atoms in a molecule, like H2 and HCl. Polyatomic molecules comprise more than two atoms in it, as in sulfur, S8, and fullerene, C60. Next is the molecules based on substance. The first one is the molecule of an element. In this, the atoms present are of the same type or same element. For example, oxygen molecule and phosphorus molecule. Next is the molecule of a compound. In this, the molecule is made up of more than one type of atom or element, like water H2O and ammonia NH3. After this, let us see how to calculate the mass of a substance. It is usually done by finding the molecular mass of the substance. Molecular mass is the summation of the average atomic mass of all the atoms which are present in that molecule. For example, methane. Its formula is CH4, so its molecular mass can be calculated as C plus 4H is equal to 12 plus 4 into 1. Here, 12 AMU and 1 AMU are the atomic mass of C and H, respectively. So, the molecular mass of methane is 16 AMU. Similarly, for glucose with molecular formula C6H12O6, the molecular weight will be 6C plus 12H plus 6O is equal to 6 into 12 plus 12 into 1 plus 6 into 16 is equal to 180 AMU. The molecular mass mentioned above can be represented in different ways. The numerical value in all these cases will be the same, but the unit and the way they are defined will differ. The first one is the molecular mass. The second is relative molecular mass. Next is the gram molecular mass, and the last one is molar mass. The first one is the molecular mass of a substance. It is defined as the sum of the atomic masses of all the atoms present in a molecule of a substance. Therefore, the mass of a molecule is expressed as atomic mass units, AMU, or U, or Dalton. Next is relative molecular mass, or RMM. It is the sum of all the relative atomic masses of the atoms in a molecule. It is the ratio of the average mass per molecule of a specified isotopic composition of a substance to 1/12 the mass of an atom of carbon-12. It is dimensionless, which means it has no unit. After this comes the gram molecular mass. The amount of a molecule, whose mass in gram is numerically equal to its molecular mass, is called gram molecular mass. The unit of gram molecular mass is gram. Last is molar mass. The molar mass of a molecule is the mass of the molecule, which contains 1 mole of the molecule. The unit is gram per mole. As we reach the end of the module, let us summarize. Firstly, we learned about the molecule. A molecule is the smallest entity that can exist independently, while an atom is the tiniest particle of an element. The molecule is further divided based on atomicity and based on substances. Based on atomicity, it is divided into monatomic, diatomic, and polyatomic, while based on the substance, it is divided into the molecule of an element and molecule of a compound. Next, the molecular mass of a substance is defined as the sum of the atomic masses of all the atoms present in a molecule of a substance, followed by RMM. The sum of all the relative atomic masses of the atoms in a molecule is the ratio of the average mass per molecule of a specified isotopic composition of a substance to 1/12 the mass of an atom of carbon-12. After that, gram molecular mass. The gram molecular mass of a molecule is the amount of that molecule that has the same mass in grams as the molecular mass in the atomic mass unit. Lastly, the molar mass of a molecule is the mass of 1 mole of the molecule.